Hi there, and welcome to Sleepy Space Traveler. I'm really glad you're here, and I hope this moment can become a gentle pause in your day. This channel was created as a quiet space for anyone who enjoys falling asleep to calm storytelling, peaceful narration, and soft explorations of science, the universe, and the mysteries around us. Here, we slow everything down. We take big ideas about space, time, reality, and existence and turn them into simple, soothing stories you can drift off to. If this kind of content helps you relax, unwind, or fall asleep a little easier, I would really appreciate it if you could like this video and subscribe to the channel to help more people discover this space, and help us continue creating these nightly journeys. Please let me know in the comments where you're watching from, and what time it is for you right now. And wherever you are, maybe lying in bed, settling into the night, or just looking for a moment of calm. I hope this time feels peaceful. I hope your mind can soften, your breathing can slow, and your body can rest. Thank you for being here. Now, let's begin. Imagine standing beneath a night sky untouched by city lights. No street lamps, no screens, no walls of concrete, only silence, stars, and an ancient darkness older than history. To the human eye, the cosmos appears glittering, luminous, and infinite. A tapestry of suns, nebulas, and galaxies burning across a vast celestial sea. But what if this picture is a brilliant illusion? Modern cosmology tells us a truth more shocking than any myth, scarier than any superstition. Everything we can see, stars, planets, galaxies, dust, gas, nebulae, makes up less than 5% of the universe. The rest, 95%, is invisible, untouchable, and nearly unknowable. Two dominant mysteries fill this cosmic void. Dark matter, a silent, unseen mass that shapes galaxies and holds the universe together. Dark energy, an invisible pressure tearing the universe apart at increasing speed. These forces do not emit light, reflect light, or absorb light. They exist beyond our senses, beyond our instruments, beyond familiar physics. They are the architecture and engine of reality, and yet, for most of human history, we did not even know they existed. This is the story of how we discovered darkness. It is the story of our blindness and our awakening. For thousands of years, humanity believed that what we saw was what existed. The stars were luminous specks pinned to celestial spheres. Space was an empty void. Gravity was a divine force, not a measurable curvature of space-time. Our ancestors mapped the sky with stories, gods, and legends. They sensed wonder, but they did not sense the invisible. Even after telescopes transformed astronomy from poetry to science, the universe was assumed to be mostly visible, if only we could magnify it enough. By the early 20th century, astronomy entered a golden age. We discovered galaxies beyond the Milky Way, stellar evolution, nuclear fusion, and cosmic expansion. We believed we were approaching cosmic understanding. Then came a revelation that cracked open reality. The visible universe could not explain its own behavior. Stars orbited too fast. Galaxies rotated too quickly. Clusters refused to fly apart. Something unseen, something massive, was holding cosmic structures together. This something was not a star, gas cloud, or black hole. It was not made of atoms. It did not glow, burn, or scatter light. It exerted gravity and nothing else. Astronomers called it dark matter. This was the first clue that the universe was not built of light, but of shadows. The discovery of dark matter was not a triumphant moment of clarity. It was a reluctant admission that the universe made no sense. In the 1930s, astronomer Fritz Zwicky studied the Coma Cluster, a swarm of galaxies bound together in deep space. He measured the speed of galaxies orbiting the cluster's center. They were moving so fast that, by traditional physics, the cluster should tear itself apart. But it did not. Zwicky concluded there must be invisible mass providing gravitational glue. He called it dunkle Materie, dark matter. His colleagues laughed, dismissed, ignored. It took decades before Vera Rubin, mapping the rotation curves of galaxies in the 1970s, proved that stars at different distances from galactic centers moved at the same speed, defying Newtonian expectations. Galaxies should have fast inner orbits, slow outer orbits like planets around the Sun. But galaxies moved differently. Stars far from the center moved too fast, as if pulled by enormous invisible mass. Rubin's discovery was not glamorous. It was unsettling. The visible mass of a galaxy could only explain a fraction of the gravitational force required. Thus emerged a new cosmic ratio. Visible matter, 5%. Invisible matter, 25%. But this was only half the story. The other half would shake cosmology to its core. By the late 20th century, astronomers believed the universe was slowing down. Gravity, they assumed, would eventually halt cosmic expansion. Perhaps the universe would collapse in a fiery Big Crunch. Perhaps it would stabilize in eternal equilibrium. Then came the revelation. Not just unexpected, but impossible. Two teams of astronomers studying distant supernovae in the 1990s discovered that galaxies were not slowing down. They were accelerating away from one another. Space was expanding faster with time. Something was pushing the cosmos apart. It was not matter, not gravity, not radiation. It was a mysterious repulsive energy permeating the universe. Scientists named it dark energy. The name was meant to be neutral, but it carried a chilling implication. The universe was filled with a force we could neither see nor measure, and it dominated all of existence. Dark energy now accounts for approximately 70% of the universe. Thus, the shocking cosmic pie chart: dark energy, 70%, dark matter, 25%, ordinary matter, 5%. The universe is not made of stars and atoms. It is made of darkness. This realization forced cosmologists to redefine everything. The visible universe is not merely small. It is negligible. Atoms, the building blocks of chemistry, biology, stars, planets, oceans, DNA, represent a cosmic minority. The periodic table applies only to 5% of existence. Everything humans have ever observed, measured, built, burned, imagined, all of it is made of ordinary matter. The rest, the overwhelming majority, is invisible, not metaphorically. Literally, the cosmos is not a blazing cathedral of light. It is a vast, black ocean whose waves we cannot see. Galaxies are bright islands floating in a darkness deeper than space itself. Dark matter does not shine, reflect, or react to electromagnetism. It passes through matter, detectors, planets, and bodies. Yet, without it, galaxies would disintegrate. Dark matter acts as scaffolding, a hidden structure upon which galaxies form. Computer simulations show that galaxies are built inside dark matter halos, invisible spheres of gravitational influence. As the early universe cooled, dark matter clumped, forming gravitational pits. Ordinary matter, atoms, gas, dust, fell into those pits. Stars ignited, galaxies formed, clusters emerged, cosmic webs stretched across billions of light years. In this picture, dark matter creates structure. Dark energy tears structure apart. One binds, the other dissolves. We live in the tension between these two invisible forces. If dark matter is cosmic bone, dark energy is cosmic breath. It does not cluster. It does not attract. It repels. It pushes space-time outward, accelerating cosmic expansion at an ever-increasing rate. This discovery transformed cosmology. The future of the universe is not static, not cyclical, not collapsing. It is accelerating toward a state of increasing emptiness. Galaxies will drift apart. Stars will fade. Light will thin. Interactions will vanish. The cosmos is headed toward isolation, fragmentation, and silence. Perhaps trillions of years from now, the night sky will be empty. No galaxies, no stars, only darkness. Dark energy is not merely powerful. It is dominant. It determines the destiny of existence. Why is this darkness invisible? Because physics is built upon light, its emission, reflection, and absorption. Telescopes, detectors, sensors, they measure photons. But dark matter and dark energy do not use photons. They exist outside electromagnetic interaction. Imagine trying to map an ocean with a flashlight, but the water neither reflects nor absorbs light. You would see nothing. This is our universe. We are blind creatures with luminous tools. We measure light in a cosmos of shadow. Science does not surrender to ignorance. It hunts it. So physicists devised methods to sense the unseen indirectly. We look for its gravitational footprint, galactic rotation, gravitational lensing, cosmic microwave background distortions. We build underground detectors deep beneath mountains, shielded from radiation, waiting for a dark matter particle to collide with an atomic nucleus. So far, we detect nothing definite, nothing measurable, nothing confirmed. Decades of experiments, billions of dollars, thousands of scientists. Still, not a single dark matter particle has been conclusively identified. Yet we know it must be there. Reality itself demands it. The structure of the universe resembles a web, a vast filament network spanning billions of light years. Galaxies gather at nodes along invisible strands. What shapes this web? Not baryonic matter, not stars or gas. It is the gravitational behavior of dark matter, etched into spacetime. The cosmos is not random. It is architected by an unseen hand. Science is often portrayed as confident, empirical, and precise. Yet the discovery of cosmic darkness did not bring certainty. It brought humiliation. We realized that the universe is stranger than we imagined. Our models are incomplete. Our instruments are primitive. Our laws may be limited. For thousands of years, humans looked upward with pride. We believed we stood at the center of creation. Now we face a harsher truth. We understand only the glowing surface of reality. The universe is not made of atoms and forces we can study in the lab. It is made of darkness, structure, energy, and fate. And we barely know its nature. Scientists propose competing models. Weakly interacting massive particles, WIMPs, axions, sterile neutrinos, primordial black holes, entire families of undiscovered particles, exotic fields with unknown interactions. The search is not merely physics. It is metaphysics with equations. We are trying to decode a hidden layer of existence. If we find dark matter, it may lead to new particles, new forces, new dimensions, new physics beyond the standard model. The universe may be deeper than we ever imagined. Dark energy demands a grim conclusion. The universe is expanding faster over time. Eventually, distant galaxies will disappear from view, their light stretched beyond detection, their existence erased from perceptual reality. The night sky will dim, cosmic structure will thin, gravity will lose, darkness will win. This future is not poetic, it is mathematical. We inhabit a universe where light is temporary, but darkness endures. This story is not just astronomy, it is existential. It changes our conception of matter, space, time, reality, consciousness, meaning. We do not live in a brilliant universe with islands of darkness. We live in a dark universe with islands of light. Humanity, with all its wars, gods, dreams, and tragedies, is a brief spark floating in a cosmic ocean that does not glow. Understanding the universe forces us to confront humility. We are not masters of reality. We are children staring at shadows. Modern cosmology stands at the edge of knowledge. We have equations without explanation, effects without causes, measurements without mechanisms. We need a deeper theory, one that explains what dark matter is, why dark energy exists, how gravity behaves, how space-time evolves, and whether reality has hidden dimensions. This could be the next revolution, as transformative as Newton, as radical as Einstein, as unprecedented as quantum mechanics. We stand on the threshold. The future of science is darkness. The night sky is a veil. Stars are punctuation in a cosmic manuscript written mostly in invisible ink. The universe does not shine. It hides. It withholds. It conceals itself behind forces we cannot touch and matter we cannot see. Yet, despite this, humanity persists in its ancient instinct to decode the night, to turn darkness into knowledge, ignorance into discovery, silence into meaning. We may never see dark matter with our eyes. We may never grasp dark energy with our senses. But we live in a universe that invites pursuit, a universe where illumination is rare, but revelation is possible. In the end, the cosmos teaches us a profound truth. Light is precious because it is rare. Darkness is the default condition of existence. The universe is mostly invisible. But we, fragile, finite, luminous creatures, choose to see. The story of cosmic darkness is not a neat tale of discovery. It is a puzzle assembled from scattered, conflicting clues. Astronomers did not find a single piece of evidence and triumphantly announce, "Here lies the invisible majority of the universe." Instead, they kept uncovering contradictions. Wherever the equations of physics met the behavior of the cosmos, there was a gap, a discrepancy between expectation and observation. Galaxies rotated too fast. Clusters held together when they should fly apart. The universe expanded when it should slow. These inconsistencies produced a new scientific reality. We understand the universe only through its errors. Dark matter and dark energy were forced into theory not because we saw them, but because the universe was broken without them. When Einstein proposed relativity, the cosmos became a continuous curved geometry. When Hubble discovered expansion, the universe became historical. When dark matter entered physics, reality became a hidden structure. But the emergence of dark energy did something unprecedented. It introduced a force more dominant than matter, gravity, light, or time, operating beyond current theory. We are no longer just patching holes, we are discovering the scaffolding of existence. One of the most extraordinary properties of dark matter is its cosmic humility. It neither shines nor interacts. It leaves no trace in detectors. It whispers only through gravity. Yet it determines the architecture of almost everything. Galaxies are not free-floating islands of stars. They are embedded within invisible envelopes, dark matter halos, enormous spheroids of unseen mass. If you could see a galaxy with dark matter illuminated, you would find a tiny bright disk of stars at its center, surrounded by a vast spherical sea of darkness. The stars are incidental. The dark matter is fundamental. The spiral arms that define galaxies, their iconic structure, are shaped not by light but by the gravitational influence of something we cannot detect directly. This raises a profound reality. We see galaxies not as they are, but as their invisible skeleton allows them to be. The shape of cosmic light is dictated by darkness. In a strange sense, the universe is an artist painting with a brush we cannot see. The distribution of matter across the cosmos is not random. Supercomputer simulations show the universe as a colossal cosmic web, a network of filaments stretching hundreds of millions of light years. Along these filaments, galaxies form like dewdrops on spider silk. The web is not made of stars, dust, or gas. It is made of dark matter, the invisible framework upon which the visible universe hangs. At the intersections of filaments lie galaxy clusters, cosmic cities with thousands of galaxies bound together. Between filaments lies cosmic voids, vast bubbles of emptiness so large that entire galaxies vanish inside them. In this structure, we find meaning. Dark matter is not a passive ingredient. It is the blueprint of cosmic architecture. Matter follows gravity. Gravity follows mass. Mass follows darkness. Dark energy is more elusive than dark matter. Dark matter pulls. Dark energy pushes. Dark matter gathers particles. Dark energy scatters galaxies. Dark matter solidifies structure. Dark energy dissolves it. They are cosmic opposites, not in metaphor, but in mechanism. One binds the universe together, the other drives it apart, and neither interacts with light. They operate in a realm untouched by photons, a realm where electromagnetism is irrelevant. In this sense, the visible universe is a superficial layer, not the foundation of reality. The true cosmos lies underneath, a matrix of invisible fields that define cosmic fate. The discovery of cosmic acceleration ignited one of the greatest paradoxes in physics. Why is empty space not empty? Quantum theory suggests that even the vacuum is filled with fluctuating energy, virtual particles, ephemeral fields. But when physicists try to calculate this vacuum energy, they obtain answers trillions of times greater than what dark energy actually is. It was called the worst theoretical prediction in the history of physics. Something is wrong, not just with the math, but with the assumptions of reality. Perhaps empty space is not empty, or perhaps it is emptier than we can imagine. Physicist Steven Weinberg once remarked, "The cosmological constant problem is a monument to our ignorance." Dark energy is the universe mocking us, a sign that our deepest theories are still shadows on a cave wall. The accelerating universe has a consequence so profound that it borders on existential horror. Distant galaxies are receding faster than light, not because they are moving through space, but because space itself is expanding. Eventually, Galaxies far away will cross a cosmic horizon, beyond which their light will never reach us. They will become unobservable, erased from existence as far as the future cosmos is concerned. In trillions of years, the night sky will darken, not because stars burn out, but because cosmic expansion hides them. Future astronomers, if any exist, will look across a silent, starless void and imagine they are alone. They will have no evidence of the Big Bang, no cosmic background radiation, no galaxies. They will live in cosmic isolation, an island in a dark sea. The universe will become unknowable to its future inhabitants. We are lucky. We live in the only era when the cosmos is observable. We are witnessing the universe during its brief moment of illumination. For decades, scientists have attempted to catch dark matter in the act. They built detectors a mile underground, shielded from radiation, frozen to near absolute zero. These chambers are designed to witness a single event, a dark matter particle colliding with an atomic nucleus, a faint vibration, a tiny flash, a single whisper. But silence reigns. Scientists have witnessed nothing conclusive. No flash, no collision, no particle. This is not failure. It is revelation. It tells us something profound. Dark matter might not be made of particles at all. Perhaps it is a field, a fluid, a relic of a higher dimensional geometry. We expected dark matter to behave like familiar matter, hard, heavy, particulate. But perhaps the universe is stranger. Perhaps the darkness is not a substance, but a property of space-time. When the known laws of physics cannot explain something, we face two possibilities. 1. The laws are incomplete. 2. Our assumptions are wrong. Dark matter, dark energy, and cosmic acceleration each point to a disturbing truth. General relativity might not be enough. Perhaps gravity behaves differently at large scales. Perhaps space-time is emergent, not fundamental. Perhaps quantum entanglement creates gravity. Perhaps geometry is woven from information. Some physicists propose that dark energy is not a substance, but a symptom, an emergent phenomenon arising from the statistical behavior of space-time. Others suggest that dark matter is a sign of modified gravity, not new particles. Traditional physics may be like Newtonian mechanics, brilliant, elegant, and incomplete. The next Einstein may be among us. If the universe is filled with invisible forces and invisible mass, why assume reality stops with what we observe? Theories of cosmology suggest that our universe may be one bubble in a sea of bubbles, each with its own physics, constants, and geometry. In some universes, dark energy might be stronger. Galaxies could never form. In others, dark matter might be absent. Gravity might be repulsive. In many possible universes, life would be impossible. In ours, existence is precariously balanced. Cosmic darkness may not just shape matter. It may determine whether anything exists at all. Science often claims objectivity, but it is shaped by human expectation. We seek certainty. We crave logic. We desire coherence. But the cosmos is under no obligation to satisfy our preferences. Physicist Richard Feynman once said, "You do not like it. You are not going to change it. It is just the way it is." The universe is not built for human comprehension. Our minds evolved to navigate forests, not galaxies. We are pattern-finding primates facing forces older than stars. Our tools, telescopes, equations, philosophy, are extensions of our limitations. Yet, despite this, we demand answers. We insist on meaning. We refuse to accept ignorance. In this struggle between human fragility and cosmic indifference, science becomes a spiritual act. To study the invisible universe is not merely intellectual, it is existential. The cosmic future is not gentle. As expansion accelerates, galaxies will drift apart. Stars will age and die, matter will decay, gravity will fail. The universe is not dissolving in sudden catastrophe. It is slowly fading, a universe-sized entropy. This era is called the heat death, not because it is hot, but because it is uniform, motionless, inert. Energy will be evenly distributed. Temperature differences will vanish. Nothing will happen forever. The cosmos is headed toward stillness, a vast, ancient cemetery of dead stars and dissolving atoms. The final era of existence will not be fiery. It will be cold, silent, and perfectly dark. If darkness dominates reality, what is light? Light is the anomaly, the exception, the temporary glitch. Darkness is stable. Light is unstable. Darkness is passive. Light is reactive. Darkness fills space. Light occupies only a moment. Every photon is born from violent processes: nuclear fusion, annihilation, acceleration, decay. Light is a rebellion against entropy. In a universe ruled by darkness, light is the brief miracle. We are creatures of that miracle. We evolved in a cosmos burned into visibility by stars, brief torches against an endless night. When we search for meaning in cosmic darkness, we are not looking outward. We are looking inward. We are asking, why does anything shine at all? If only 5% of the universe is visible and 95% is dark, then we, humans, animals, planets, stars, are rare anomalies in a reality built from shadows. Our atoms are exceptions. Our chemistry is unusual. Our existence is improbable. We do not simply live in a dark universe, we live against it. Our minds create light, symbols, stories, mathematics, music, memory. Our consciousness is an emergent brightness, a flicker of order in a sea of chaos. We are luminous organisms contemplating the dark. In doing so, we defy cosmic destiny, not because we conquer it, but because we understand it. For the brief moment we exist, we illuminate a fragment of the unknown. The science of the invisible universe is not finished. It has barely begun. Future telescopes, space-based, cryogenic, quantum-enabled, will probe the deep cosmos. Particle accelerators may reveal new fields, forces, and dimensions. Perhaps we will detect dark matter directly. Perhaps we will map dark energy experimentally. Perhaps we will rewrite physics from the ground up. The next era of discovery may not be built upon bigger machines, but upon new ideas. Gravity as information, space-time as entanglement, matter as emergent, reality as computation. We may discover not just what the universe is made of, but why it exists at all. The invisible universe is not simply a scientific mystery. It is a mirror held up to human ignorance. We believed that sight revealed truth. We believed that matter was solid. We believed that space was empty. We believed that time was constant. We believed wrong. Cosmic darkness reminds us knowledge is temporary. Certainty is fragile. Perspective is limited. We are explorers within a world we barely perceive. Our instruments reveal slivers. Our equations approximate. Our language fails. Yet we continue. We ask. We wonder. We search. Because embedded in the human condition is a refusal to remain blind. We are creatures born from stardust, struggling to understand the night. The universe will survive long after the last observer is gone. The cosmic web will unravel. Galaxies will fade. Particles will decay. Dark matter itself may vanish. Dark energy may dissipate. Space-time may evaporate. The universe will return to equilibrium, a state without complexity, structure, or motion. No stars, no atoms, no time, only darkness. Not violent, not tragic, just indifferent. The universe will not remember us. It will not remember anything. The story of existence will end without a final chapter. And yet, for a brief cosmic moment, light existed. Life existed. Consciousness existed. We existed. The universe is not a cold, meaningless void. It is a canvas. Darkness is not absence. It is potential. It is the stage upon which light performs. If 95% of reality is invisible, then our struggle to perceive it is not a sign of weakness, but a sign of courage. We are small. We are temporary. We are fragile. But we are luminous. We turn darkness into understanding. We transform chaos into story. We extract meaning from silence. We are the universe awakening to itself. This is why cosmic darkness matters. Not because it hides truth, but because it challenges us to seek it. For as long as we exist, for as long as light endures, we remain the exception. We remain the spark. The universe did not begin in darkness. It began in blinding light. In the first microseconds after the Big Bang, temperatures were so extreme that matter could not exist in familiar form. Particles and antiparticles annihilated in violent flashes. Space was a furnace of radiation, not atoms. During this incandescent chaos, darkness was not yet a concept. Matter had no meaning. Structure had no direction. Light filled everything. But as the universe expanded and cooled, an astonishing transformation occurred. Darkness emerged before anything else. Before stars, before galaxies, before atoms. A mysterious form of matter decoupled from radiation and began to shape the newborn cosmos. Dark matter formed first. Ordinary matter came second. Light was an after effect. The universe we inhabit today is built upon ancient shadows older than the stars. In the early universe, space was nearly uniform. Tiny quantum fluctuations, inconceivably small ripples in the energy field, acted as seeds for future structure. If the universe had been perfectly smooth, nothing would have formed. But dark matter responded to these primordial ripples. It did something ordinary matter could not. It clumped without interacting with light. It clustered without pressure. It formed scaffolding before atoms existed. When atoms finally formed, hundreds of thousands of years later, they fell into the invisible gravitational wells carved by dark matter. The first galaxies did not arise because matter organized itself. They arose because darkness organized matter. The cosmos is a history of light captured by hidden structures. After hundreds of millions of years, stars ignited. Light pierced darkness. This epoch, called cosmic dawn, created a universe of contrast. Dark matter shaped the background. Ordinary matter illuminated the foreground. Galaxies formed at nodes of the dark matter web. Starlight exposed only the shallowest layer of cosmic architecture. To this day, what we observe in telescopes is not the universe itself. It is merely the brightest surface of a deeper, darker reality. Light reveals structure, but darkness defines it. Dark matter is not a singular idea. It has competitors, models, and categories. The three major candidates are 1. Hot dark matter. 2. Cold dark matter. 3. Warm dark matter. Hot dark matter, made of vast, nearly massless particles like neutrinos, moving close to light speed. too fast to clump, too energetic to form structure. Universe would be smooth with no galaxies. Cold, dark matter, massive, slow-moving particles, able to clump early, forms structure at all scales, predicts the cosmic web we observe. Warm dark matter, intermediate mass and speed, forms fewer small-scale structures, predicts a smoother, less clumpy universe. Cosmology strongly favors cold dark matter, but neutrinos, the ghosts of physics, complicate the picture. Neutrinos permeate everything. Billions pass through your body each second. They are real, measurable, and dark, but they are insufficient. The universe needs something more massive, more influential, more dominant, something unknown. The mystery remains unresolved. Neutrinos are the most elusive particles known. They have mass, interact only through the weak force, travel near light speed, pass through matter like it isn't there. A block of lead, a light year thick, would only stop half of them. They are almost perfect phantoms, yet they hold clues to cosmic evolution. If neutrinos had been slightly heavier, galaxies would never have formed. If neutrinos had been massless, the universe would look entirely different. We owe our existence to particles that ignore us completely. Life depends on invisible, indifferent shadows. One of the greatest puzzles in cosmology is not what dark matter is, but how it is distributed. The cosmic web reveals a fractal geometry, patterns repeating across scales. This resemblance to fractals has led to radical ideas. Is space-time fractal? Is gravity emergent from network behavior? Is the universe shaped by mathematics deeper than physics? In this view, dark matter is not a substance floating in space. It is a manifestation of geometry, a property of structure, a mathematical necessity. Darkness may not be made of particles. It may be made of shape. Dark energy remains more mysterious than dark matter. It has no known particles, no structure, no origin. It is a negative pressure woven into space-time itself, a force that counteracts gravity, a phenomenon that accelerates expansion, a property that grows stronger as space grows larger. Its behavior is bizarre. The more universe there is, the stronger dark energy becomes. This means the future universe accelerates faster than the past. Entropy increases. Complexity dissolves. Isolation grows. The universe is becoming softer, smoother, simpler, a cosmic erasure. Entropy is not chaos. Entropy is uniformity. As time progresses, systems tend toward equilibrium, not disorder, but sameness. Dark energy accelerates that process. Galaxies separate. Stars fade, matter decays, information disperses. The final state of the universe is not destruction. It is indifference, a uniform soup of low-energy particles drifting endlessly. No temperature difference, no structure, no time. The cosmos ends not in fire, but in equilibrium, an ocean without waves, a silence without echo. Time is not a universal constant. It is a consequence of entropy. Without differences, without gradients, without change, time loses meaning. In a final, uniform universe, no clocks tick, no forces act, no events occur. Time becomes irrelevant. Dark energy is not just shaping space, it is shaping time itself. By accelerating entropy, it accelerates the end of time. The arrow of time is the arrow of darkness. Modern physics suggests that our universe may not be limited to 3 dimensions of space and 1 of time. String theory proposes 10 dimensions, 11 dimensions, or more. We experience only 4 because the others may be tiny, curled, inaccessible. What if dark matter arises from matter in hidden dimensions? What if gravity leaks between worlds? What if our 4D universe floats in a higher dimensional space? Darkness may not be exotic. It may be ordinary matter we cannot access. The universe might be crowded with worlds stacked like pages of a book, utterly invisible to each other. The empty space around us may be full of unseen universes. Reality may not be built from particles, but from information. In this framework, space is data, time is computation, matter is stored information, energy is processing, gravity is compression. Dark matter may be redundant data stabilizing the cosmic network. Dark energy may be compression rate accelerating toward maximum entropy. In this view, the universe is a memory system losing coherence over time. Stars, galaxies, and minds are temporary pockets of information resisting dissolution. We are local negentropy, organized patterns in the universe tending toward uniformity. Life is a structure that delays the inevitable. Consciousness is an interface that interprets the delay. Meaning is a narrative we assign to entropy's temporary reversal. The more we learn, the stranger the universe becomes. We have measured cosmic acceleration, but we do not know why. We have mapped dark matter, but we do not know what it is. We have traced the cosmic web, but we do not understand its origin. Science answers questions by revealing deeper mysteries. We do not approach certainty. We approach complexity. We do not master truth. We uncover deeper ignorance. The universe is not transparent. It is selectively opaque. It reveals enough to provoke curiosity, but not enough to resolve it. Darkness is not just physical. It is epistemological. For thousands of generations, humans looked at the night sky and imagined gods. Now we look and imagine equations, but the motivation is the same. Wonder, fear, curiosity, meaning. We are creatures who cannot endure silence. We assign stories to stars. We turn randomness into destiny. We transform absence into myth. Even today, in the age of cosmology, darkness is not merely scientific. It is psychological. To accept that 95% of reality is invisible is to accept that we are born into ignorance, and that we die incomplete. Scientific discovery does not make the universe meaningful. It makes it strange. We learned that Earth is not the center, that the Sun is not special, that the galaxy is one among trillions. Darkness is the final humiliation. It tells us we do not see most of existence. We do not understand cosmic structure. We cannot predict our own fate. Yet, despite this, we seek. Curiosity is not logical. It is biological. An instinct born from risk, shaped by evolution, weaponized by intelligence. In a universe ruled by darkness, meaning becomes an act of rebellion. The invisible universe is not a threat. It is an invitation to explore, to question, to marvel. Darkness is not an obstacle. It is a frontier. The fact that the universe hides itself is not an insult. It is an opportunity. If everything were visible, curiosity would be unnecessary. Ignorance is not an accident. It is the engine of discovery. We are creatures who evolved beneath a star in a cosmos ruled by night. Our entire cognitive architecture is shaped by contrast. Light without darkness is invisible. Knowledge without mystery is meaningless. Existence without curiosity is inert. We look up because we are built to. We seek because we cannot stop. In a universe of shadows, light is more than physics. It is awareness. The cosmos is not conscious, yet consciousness emerged from it, from matter, from atoms, from starlight. We are the visible universe becoming aware of the invisible one. This is our strange fate. We are temporary, we are insignificant, we are finite. Yet we are the only known phenomena capable of recognizing that the universe is dark. We do not just emit light, we understand it. We are not children of darkness. We are children of contrast. And as long as we remain aware, as long as we ask, as long as we seek, darkness is not the end. It is the beginning.